recording now. Okay, so we're back. We've both got our circuits that we're testing, so I can see what you see now and what I'm building. Where we've tested the voltage of the battery and our ammeter. We've got one battery and a light bulb so far in our circuit. Okay, so the next thing I want you to do, we're going to add another battery, and we're going to measure and record the voltage and current again. So this time, we'll take your voltmeter and just move the leads off. And then right-click the junction where the wire meets the battery.
Junction?
Oops, sorry, left-click this one. So that little circle where the wire meets the battery, just click that and then hit cut. And that will split the split the circuit. Yep, so hit the cut sign. There we go. And we're going to add another battery in there. Okay, then we're going to do the same thing. So measure and record the voltage and current again.
Oh.
Okay, so that was with one battery. Battery and one light. We had a 9-volt battery and we got 0.9 amps of current through the line. Now we have two batteries and one light. And we have 18 volts and 1.8 amps of current. Okay, what could you tell me about the relationship between the voltage and the current?
So voltage is as current increases, voltage also increases.
Okay, so that means
by the same unit.
They are directly proportional. Okay, so voltage is directly proportional to current. Okay. So let's go ahead and we're going to repeat doing this again. But we're going to add one battery at a time until we get up to 7. And I'm just going to record the different voltages. And then we'll use that to make a best fitting line and see what happens for the slope. Okay, so we're going to split this again. We're just going to keep adding more and more batteries to our current, or to our circuit, and recording that voltage and current. Okay, so tell me what you get with 3 batteries.
27 voltage and 2.8 ampere. No, ampere?
2.7 amps, we can say.
Yeah, amps.
So 27 volts and 2.7 amps. Okay, 4 batteries.
36 volt, 3.6 amp.
Okay, we'll go for 5.
45 volt, 4.5 amp.
Okay. And 6.
54 and 5.4.
Okay, 54 and 5.4 you said? And 7.
63 volt and 6.3.
Okay. So I'm going to graph this so that X is current and Y is voltage, and we'll make a best fitting line.
Mm-hmm.
I'm going to do that. So our x-axis is current. Y-axis is voltage. What's our graph going to look like?
Linear, positive linear.
Okay, a positive linear function. So this would be increasing by 0.9 every time, right?
Mm-hmm.
5, I need some more space. Okay, roughly like that. And then voltage, we are increasing by 9 each time. I thought I had a way to put a ruler on here, but I guess not. So I'm going to end up with a linear function.
Mm-hmm.
What would the slope of this line be?
Slope,
Mm-hmm.
V over current.
Okay.
V over I.
Yep. So current's represented as I, but its units are amps. So slope dV over VI
Mm-hmm.
is equal to what?
Um, resistance.
Uh, you're right. But what's the slope for this graph in particular?
V over I.
What's the number?
Oh, 1.
Okay. Is 1. Okay. So let's go back to our circuit. And we're going to see if we can get the resistance here. So on your circuit,
Uh-huh.
there's an option to show values on the top right. I want you to click that checkbox so that you can see the
Oh,
values.
I have to put this back. Yay.
Okay, so how much ohms do we have?
10 ohms.
10 ohms. Okay, I think this should be 10 actually. We went up by 9 and we went over by 0.9, right? So 9 divided by
Oh, yeah.
0.9 is 10. Okay, this is 10 ohms. So our resistance was our change in V over change in I. Or we could say V over I is equal to our resistance.
Mm-hmm.
Therefore, V equals IR, which is Ohm's law.
Mm-hmm. Yay.
Okay. That's all we really need for today. I'm going to move into Kirchhoff's two laws tomorrow. And we'll keep playing around with this AC circuit, if that's all right. Homework is still to finish. Sorry. Homework is still to finish the day one stuff on the packet that you got yesterday.
Is it day one stuff that we did right now?
It's similar. You're going to be using the DC circuits, but I believe you're still proving Ohm's law.
Oh, okay.
All right. I'll see you tomorrow.
Bye bye.
Goodbye.